Rational equations are equations that simply involve one or more fractions. Rational expressions can be written as fractions, so rational equations have fractions in them. So these equations, the way you see it right now, if we look at this example, doesn't look like our regular equations that we're used to seeing, but we can make it look like an equation without a fraction. And to do that, if you look at the to solve part here, you find the least common denominator of all the terms and then multiply every term by that least common denominator. And you've done this before, so once we do a few, it should look familiar. So what this will do is when you simplify it, then it'll eliminate all the fractions, so you just have a more simple equation to solve. And the reason we can do this is because whatever we multiply times, which is our least common denominator, will multiply everything. So as long as we multiply every term, we'll keep our equation equivalent so we don't change its value. So the least common denominator here, the two denominators we have are just 3 and 4. Okay? When you only have numbers in the denominator and no variables, you can just multiply those two numbers together. It might not, when you do that, it might not be the least common denominator, but it's still going to get you the answer that you need. But if we do 3 and 4, the least common denominator is 12 if we multiply 3 times 4. So what it looks like then is we're going to multiply every single term, and notice I'm using parentheses for multiply. We'll multiply by 12. So when you do that then, notice here we can simplify. Now we have 12 divided by 3. Well, 12 divided by 3 is 4. And then x stays with that. And then in the next set, we have 12 times 3, and then divided by 4. So 12 times 3 is 36, and then 36 now divided by 4 is 9. So that would give us plus 9x equals, and then over here, just 2 times 12 is 24. So now we have a nice, more simplified equation to solve that does not have fractions. So we would simply combine our like terms. 4 and 9 is 13x equals 24. And in this case, when you divide, you don't get a whole number, and that's okay. You're not always going to get whole numbers for answers. So we're going to get x equals, and then another thing is 24 divided by 13. That does not give us a whole number, and I can't simplify that fraction. So what I want you to do is please leave your answers as improper fractions. So leave it as 24 over 13. So we're going to leave our answer as improper fractions. They're just easier to work with than mixed numbers if you had to go further with this. Like if we had to take this x value and use it to do more solving, it's more user-friendly to leave it as an improper fraction than to write it as a mixed number. So we'll leave it as 24 over 13. Now we're going to do a couple more of these to get some practice, and if we have a variable in your denominator, so here we have an x plus 3, we have an x squared plus 3x. So whenever there's a variable in the denominator, so in this part, dividing by variable expression, it's possible that you have extraneous solutions. And hopefully that word sounds familiar because, again, you've done this before and you've talked about these. But extraneous solutions, they make the denominator 0. And we cannot divide by 0. So we never want that denominator to be 0. So that's why we call them extraneous solutions. Like, yes, I get them as a solution when I solve, but when I go back and check my answer, it creates an undefined value because we cannot divide by 0. So to find your possible extraneous solutions, whenever you have a variable in the denominator, and I'm just going to call them, I call them excluded values, might be another word that you used. So underneath here, I'm just going to put a note, excluded values. Maybe that sounds a little bit more familiar to you. Those are interchangeable with each other. So extraneous solutions, excluded values mean the exact same thing. So when I do this, I use excluded values. So I say the excluded value. would be whatever makes a denominator 0. So here, to make that a 0, I would just substitute in a 0. So an excluded value would be x equals 0. To make this value 0, x plus 3, I would need a negative 3 in for that x. So negative 3 is an excluded value. And then our next denominator has an x squared. So whenever we have an x squared, we're actually going to factor this to simplify it down. So I'm going to factor out an x, and that would leave me with x plus 3. If I took an x away here and if I took an x away here. So that gives me then the same values I have in x already that I accounted for 0, and then x plus 3 is the same, so that excluded value would be a negative 3 as well. So my two excluded values are 0 and negative 3. What that means is if I solve and I get either of those as an answer, it cannot be one of my final answers. All right, so I made some marks up there. So I'm going to rewrite my original equation. 6 over x minus 2 over x plus 3. And then I'm going to keep my denominator here, 3 times x plus 5. But I'm going to use my factored denominator because whenever you have an x squared in your denominator, you do need to factor it to help you get your least common denominator. So let's just go ahead and make a little note here. So we are going to use a factored version to find the least common denominator when there is an x squared. So go ahead and jot that down. And then we want to make sure when we identify our least common denominator then, is we want to make sure that we include everything. So for example, we have a singular x here, and we have this singular x here. So x is going to be a part of our least common denominator. And then the other piece we have is the binomial x plus 3. And then we have the same binomial x plus 3, so that x plus 3 will be a part of our common denominator. Don't duplicate them because that's just going to make your solving more complicated. It's fine, but the solving part is going to be a little bit more difficult because you're going to have larger exponents to work with. So you just want to pick one of everything. So for example, we just put the x in one spot, and we put the x plus 3 in one spot in our least common denominator. So now we'll go through and we'll multiply every term by an x and by an x plus 3. X and an x plus 3, and then x and an x plus 3. When you do that, you should be able to simplify every single denominator. So in my first fraction here, I can simplify. I have an x in the numerator and an x in the denominator. So I'm left with the 6 in the numerator and the binomial x plus 3. So we'll distribute 6 times x, and 6 times positive 3 is positive 18. In my next fraction, and pay attention, we have a negative here. So this is like a negative 2. We can simplify the x plus 3, this identical binomial. So we're just left with a negative 2x. And then we have our equal sign. And what can we simplify? We can simplify everything in the last fraction, which is always nice. So we can take the x, the x and the x, and then the x plus 3 and the x plus 3. So we're just left with this 3 to distribute to the x plus 5. So that gives us 3x plus 15. Good. Now, once you've eliminated all those fractions and done so carefully to make sure that this step is correct, then we just need to solve. So we can combine 6x minus 2x on that side is 4x. Keep that plus 18. Equals 3x plus 15. Subtract that 3x over, or you can subtract the 4x. I like to subtract the smaller one to keep it positive. So that gives us 1x plus 18 equals 15. Subtract your 18. Now I'm going to write this 1x as just x equals, and then 15 minus 18 is a negative 3. Now let's analyze. Remember, we had two excluded values. Our two excluded values were x equals 0 and x equals negative 3. So because your excluded value is the only answer you got, we cannot use this answer because it's an excluded value. So I don't have any answers to go off of. So my final answer on this one then is no solution. So don't forget to go back, because I know the solving process can be long, but don't forget to go back and think about those excluded values after you get the answer for your solving. All right, and then just a couple more examples here to get a little bit more practice. So in this case, the only thing we have in the denominator is an x. And so we do have an excluded value. The value that would make this denominator 0 is just 0. And then your least common denominator, the only denominator is x, so your least common denominator would just be x. So we're going to go through and we're going to multiply everything times x. So that gives us, if I zoom in here, x divided by x simplifies, so we're left with 15 here. This doesn't have any simplifying, so that's a negative 4x. Here we can simplify the x's and we're left with just the 6. Got that equal sign in between there. And we've got a plus 3x at the end. That leaves us with a fairly simple equation to solve. So I'm going to add this 4x to the other side. So we get 15 equals 6 plus 7x, subtract the 6. Get 7 equal, not 7, 9. Equals 7x, divide by 7. So that x value will be a fraction. And 9 divided by 7 doesn't simplify. So like we said before, we're going to leave that as an improper fraction, 9 over 7. And let's remember, we did have an excluded value. Our excluded value was when x is 0. So 9 over 7 is a good answer because it's not our excluded value. Our last example here gives us one more practice. And if we look at the denominators to figure out the least common denominator, we've got a binomial x minus 2, a binomial x plus 3, and then a trinomial x squared plus x minus 6. Now remember we said if you have this x squared, you want to factor to help find your least common denominator. And if you look for a common factor between those three, they don't all have an x, and they don't all have a number that we can factor out. So we're going to take this trinomial and we're going to factor it into two binomials. Good review here. So to get our x squared, we need to have x times x. And then remember, we want then to find two numbers that multiply to negative 6, but those same two numbers have to add to 1. So to get negative 6 and adding to 1, I can use 3 times 2. Because I want to get a negative 6 when I multiply, one of those has to be negative. So I'm going to make this a positive 3 and a negative 2, because then if I check, if I take negative 3 plus 2, I get a positive 1 in the middle. So that's a good review of factoring trinomials. So now we can see our least common denominator is going to have an x minus 2 in it, and it's going to have an x plus 3 in it. So my least common denominator is going to be x minus 2 and x plus 3. So that's what we're going to multiply every term by. So if I go along the top here, I'm going to do x minus 2 times x minus 3 here. And what that's going to do is that's going to simplify the x minus 2's. So we'll just be left with 1 times x and 1 times negative 3. And then if I do the same thing here, x minus 2 and plus, that should be a plus 3. Okay, let's change that. Sorry, this should be a plus 3 here. X plus 3, And then here the x plus 3's cancel, so we're left with a positive 3 times x. So positive 3x, and then positive 3 times negative 2 is a negative 6. And then we have our equal sign. And if we do the same thing with this term, if we multiply by an x plus 3 and an x minus 2, both of them are going to cancel out. So we are just left with this 4, and it is positive. So equals 4. All right, let's go ahead and solve. So we have 1x and 3x, so 4x, and then we have a positive 3 minus 6. So minus 3 equals 4. We'll add the 3 over. So we get 4x equals 7, divide by 4. So again, we get an improper fraction. Leave it that way, please. 7 over 4. Keep in mind, if we did excluded values here, our excluded values from our denominator would be, and we didn't do those at first, so let's look at what they would be. It would be a negative 3 and a positive 2. So we are good to go with this answer because it is not one of our excluded values.